This is actually a pretty old video. Rob Pike, one of the grand old men of computer science who works at Google, put this together for us back in 2003. This is a map of basically search activity graphed against time, with time being represented by the world and the sun and all the rest. So what you'll notice here is that people are kind of asleep over here, and as they wake up, things will light up with more search traffic. Sort of using, so you'll start seeing it already here. It's all bright and blinky and everything. People over here are falling asleep. Anyway, so once Rob Pike did this great search with his fellow Amit Patel, graphing when people looked for certain words during the day. Staying away from the pornographic ones. My favorite was sort of insomnia. It like peaks at around 1:30, 1:45, it turns out, in the morning, obviously. So just a little fun thing to go with the music I was playing earlier. Let's let me get rid of this junk so it doesn't bother you anymore. Or me, because I'm easily distracted like a 4-year-old. Okay, so Google and open source. I am here. Yeah, very clever, huh? I can type. So, yeah, it's late at night on a Friday. So here, in the beginning of my talks, what I do is I come up with some bogus excuse for every mistake I'll make. So it's late on a Friday. We've all had a lot of burritos. We're all really sleepy. So thanks for giving me your time to waste while we're all sleepy and making horrible mistakes. So who am I? Man, that is a big screen, isn't it? I was saying to myself when I was watching another talk, I was like, I'm not going to hide behind that desk. You look like you look like this when you're back here, from where I was sitting, anyways. It's like, hi. And I didn't really want to hide, but I guess I'm kind of going to, or I could just sort of spin this around. There you go. Is that better? Because I know you don't want me hiding. You wouldn't like me when I hide. Okay. The funny thing is I'm doing it for the slide that's about me. I should know this stuff, right? I've been living it for how many years? Well, it turns out about 10. So I discovered Linux in 1994 and became a happy user of it. I was a college student taking my computer science degree. Well, taking is a strong word. I actually finished it about 10 years after that. But I was studying for my computer science degree. And the Sun Lab, which was filled with all these crafty old Sun workstations, was really slow. And it was in a room that had really poor air conditioning. It was filled with sweaty computer people. So I'd walk into this room, try to do my homework, wait in line, and it would get stinkier and stinkier and sweatier and hotter. And I said, you know what, there's got to be a better way. And the better way was Linux. And that's how my career started in this whole thing. What do I do now? I'm the open source programs manager for Google. It's a company on the internet. What do I do? I have a very boring job at times, but it's very important to me and to the company, I assure you. So I run compliance, which means that when we use open source software, that we use it well, that we use it within the boundaries of the license. And this is really important, because open source actually doesn't ask very much of you, except that you do what the license says. And these are really easy to get into. I talk about it for like 3 seconds in this slide. But in a large company, doing that means process and engineering and all this other stuff. It's kind of important. So that's kind of what I do. I also make it possible for Google engineers to patch into open source projects and to release new projects. So that's a lot of fun. I get to give a lot of code away. And I run a program called the Summer of Code. I saw a couple of summer coders here. Raise your hand if you took part in summer code this or last year. Oh, 4th, that's so cool. So it's 5. Wow, cool. That's actually the most that's ever raised their hand at a talk like this. And I'll talk about that at length. It's actually something I'm very proud of, and I'm very amazed that we're able to do. And also I'm involved in APIs tangentially. So Dan also. Raise your hand, Dan. Dan also works on APIs. I used to work at a site called Slashdot, which you Plains people should know about, because it came from here in the heartland in its own way, over to Michigan. And wrote a couple books, blah, 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 blah. Okay. So, agenda. Oh, you see, I don't like agendas. So, a long time ago, Google was small. This was Google, called Backrub back then. You'll notice some pretty interesting things. So this is how much of a dork I am. Here's my little remote. My remote has this red laser. I don't like red. I like green. So this is the old Google, right? And what you've got heterogeneity. We've got Sun machines hiding in the corner. We've got IBM machines running God knows what. A Dell. but mostly running Linux, right? Oh, except for that one. That's not a Sun. So, you know, they were at Stanford. They could get Suns basically for free, and Legos too. And so they threw together Backrub just using whatever they had on hand. So, yeah. But now I have to switch back to my little remote because I put it down. This is I thought that it was really cool. I was walking through your ACM room, and I noticed that we share an engineering love of Legos. In fact, I'd say that every engineer probably has a love of Legos, and that's just the way it should be. So yeah, it was a raid case. Basically, you know, every time I look at this, though, I think, you know what? These are probably extraneous. You probably don't really need them to keep the machine running, but maybe it's for airflow. I don't know. But I think it might be gratuitous. Whatever. Speaking of gratuitous, so as we grew, we realized that running Linux worked for us, and running Linux on commodity PC hardware also worked quite well for us. So this is what we did. We got a bunch of motherboards, 4 per rack. I think it was 4, 2, might be 4, but definitely 4 CPUs per 2U. And then we installed network cards into them, and we put memory here, and then put the hard drives on top of the memory. It's a very advanced way of putting the hard drives in, by the way. And then here are the power switches, and they sat on these metal trays with a layer of corkboard on top of them, because cork, you know, being non-conductive, is the ideal computer-making material. So, and I don't know if you can see this back here, but those are all fans. It's an entire back plane, basically, of fans that were hand-woven by the founders. All right, whatever. But, yeah, no, so everybody who worked there basically had to put these damn fans on. There was like, I think 20 of these racks made. One of them's in the Computer History Museum, one's in the lobby, one's in my house. But, you know, I'm sure we recycled it into whatever came next, right? But, yeah, the problem was, okay, I would like anyone to come up with a problem for this. Just raise your hand. What's wrong with this architecture? Okay, you. Water? Spills? No, there's no spilling in the... People don't take drinks into the server room. A friend of mine at Rutgers, they used to have a keg that they put in the cooling coils in the data center, but yeah, Google didn't do that. This wasn't in a server room. This is above a bike shop in Palo Alto, for God's sakes. There's no server rooms, please. Another architectural problem. Yeah. Heat. Ah, that's good. Actually, it's funny. A competitor of Google's, and I won't say who, they came to us when I was working for a hardware company, and they said, you know, we're going to call the fire marshal on those guys. I've seen their hardware, and they tell us all about this hardware. I'm like, they're really doing that? They're like, yeah. And I'm like, it'd be kind of wrong to call the fire marshal, though, wouldn't it? And they're like, you know. So people were very competitive. It was the boom, whatever. I don't know if they did or not. Regardless, they got away with it long enough to use it. So, yeah, heat was a problem. That's why we had all those fans, though. Yeah. Ah, and you get right to the crux of the matter. So, to take one of these machines out and fix it, you had to shut down 4 machines. And, as you pulled it out, these cables on the side here would catch on every little pokey bit on every side. Pokey bit, it's a enhanced Google computer science term. So, it would catch on these bits here, and it would snap cards off. I mean, these poor nicks, you know. I mean, we probably broke a zillion of them, and it was a real problem. Anyways, let me continue with the advancement of Google through the years. So, we were getting smarter. We hooked up with a company. These are, I think, were rackable made. Advanced cooling mechanisms, you'll see here. I can't tell you how many companies I've worked where we've had this same one. So, SourceForge, we had one of these stand-up things that went you know, in our upstairs server room, and one day it exploded. So... It like there was this like black plastic smoke coming from it. It's like a $4, $5 stupid thing we found on eBay. We're like, hey, it works, you know, and it didn't work, and it blew up, and fire alarms went off. There was also a fire in the air vents once, but we won't go there. That's a whole different company. Google's really well organized. Our fan worked. Okay. And you also notice the power distribution power strips here. Yeah. I love this picture. But yeah, so high density, lots of commodity PC parts. You're not looking at like, you know, the Intel Advanced Xeon, Advanced Server 1000 billion, 1 billion, 1.4, or whatever. You're looking at Pentium 3s, Pentium 4s, you know, made for your desktops, made for, you know, the machine that's under here. This is not, you know, their server platform version 16 billion.1, you know, because that's kind of dumb. Similarly, This switch here is a funny switch. This is the ProCurve 1600M. And the ProCurve 1600M, you'll remember, or not. When it shipped with 2 blades installed and 1 power supply and like 8 empty blades and 1 empty power supply slot, right? And it was $400. What a price, 100 megabits ports back then, awesome, right? So you could buy it with 20 ports and $400, $20 a port. That's cool. Well, what if you want to add more blades to it? Well, then it's $300 a blade or $200 a blade. It was really expensive. So we're like, oh, wait a second. So we want redundant power. How much was an extra power supply? Oh, it's $200. So we got to give you $200 and $300 and $300 to get what's already in this $400 box. And they're like, well, yeah, but the box is like a loss leader. And we're like, oh, okay, so we'll take 20 loss leaders. And then we threw out the chassis and installed them in here. Found out very rapidly that once you get past about 6 of these blades, you max out the back planes. That's where we'd stop. So we had a lot of empty chassis. But yeah, again, all running Linux, all running commodity hardware. And we're at the point now as a company where we're like, we're going to be using a lot of data center power and bandwidth and air conditioning. And data centers would say they had this amount of power in AC, but, hate to say, they didn't. So we'd make do. And suddenly, data centers would run out of power. And so we'd have to make more data centers, whatever. Yeah, as I said, make it reliable in the software. Skip making it reliable in hardware. You can do it in hardware, but it costs you a fortune. You end up spending too much darn money. And especially back then, in 2000-ish, if you wanted a reliable PC hardware, it was really expensive. And frankly, the more reliable, quote, it was, the less reliable it was. I can't tell you how many flipping Adaptec RAID cards I trashed in DAC 960s and DAC 1100s. They were awful, just awful, awful pieces of hardware. They bring you RAID, but then when they go down, you can't recover them. And it's like, what? Anyway, so I don't want to go on a rant, but this is the right way to do it. Put it in the software. And that's what we did. But our hardware kept getting better, and we kept getting better about installing it. So between this and this is, I think it's about, 3 hours is what they told us? I didn't believe it. It's more like 4. But we were really good about filling these rooms up with machines. Have loading dock will travel, right? So, again, all running Linux, all running Google. So, this is sort of where we are nowadays. How many seconds has it been up? Okay, Urs gets upset if I show that more than 4 seconds. So, that picture was 4 seconds or so. And we're getting very, very good now at cramming lots of hardware, and that's sort of the story there. And, so we have 6 computers now, and, 7 computers now. And we're 8, and we're growing all the time, and that's great. And we're able to do that because we control our software destiny. And you'll hear me say that a couple times during this talk, which is a little too, I don't know, what's the preacher-y thing? Evangelical of me. But I mean it. I damn well mean it. Google doesn't answer to anybody outside the company when it comes to software, and that's pretty important. So what am I here to actually talk about? Well, that's a good question, right? So I'm here to talk about free software. I'm here to talk about open source. I'm here to talk about how Google has a relationship with these folks. And to do that, there's some of you in this audience who are not wholly familiar with the history of open source. And even those of you that are probably don't realize one of the guiding events of Richard's life was this printer thing. And maybe you've even heard the printer story, but you have not internalized it. And that's what I'm going to do today. I'm going to jam Richard into you. 8:45 at night. I can say anything. Qdoba burrito. Anyway, so Richard had a broken printer. He wrote a patch to fix a problem it had with printing. Every second, between the second and third page, it would jam up. It would jam up because its buffer was screwed up. So it could handle about 2 pages, but if you put in more, it would screw up the buffer, which would screw up the printer, which would cause you to jam this printer, which was the size of this room. Maybe not, but it was quite large. And when it got jammed, you basically had to disassemble it and bring in a crane or whatever you do with these old laser printers from Xerox in the 80s. And yeah, so Richard said, you know what? It's always happening between the second and third page. I bet you it's a problem in how it's handling the incoming memory. Logical. I'm going to grab my water here. Hold on. So he wrote a little patch. that would stall and slow down and wait and say, oh, there was 2 pages, let's hold off. Okay, here's another one. Okay, so he wrote this patch, and he called up Xerox and said, hey, I wrote this awesome patch. And they're like, really? Like, yeah, you want it? And they're like, sure. We're going to send over a lawyer with some documents for you to sign. He's like, what? I fixed a problem with this hardware in my lab? Yeah, you can open it for me? Thanks. I could have. It's just I would have had to stop my talk like I am right now. Thanks, Dan. Anyway, so... So anyways, he didn't want to sign away his stuff because he had fixed this thing. He wanted to fix it for everybody and not have it become part of some support contract. And he got upset about it. Maybe pathologically upset, but he got upset. And so he decided to start a global movement to give everyone a free operating system, which sounds illogical, but it really is the logical end to that kind of thinking. So he started the Free Software Foundation, and he wrote the GPL. The GPL is a license that covers open source software, well, free software. And he started writing some tools. He wrote an editor. He wrote some fairly fantastic compilers, which went on to become the most important compilers in computer science. And now the GPL probably covers about half of all open source / free software. And that's a non-trivial number, by the way. So if you do a study of free software and open source software, I mean billions upon billions upon billions of lines of code, probably ranging in the trillions, you will find over half of it is often GPL. So this is a very important license. This was a very important movement, and it was a very momentous thing that he was doing. So this guides everything around the GPL, and it guides an awful lot of free software. Not as much in the United States, strangely enough, but in Europe especially, you'll find that the GPL is very, very important. So ignoring it is foolish. Ignore it at your peril. So basically the GPL is this ideal expressed as a software license, right? And there are other licenses that are also very popular. The Apache software license says, yeah, take it. Just don't sue me. Huh? All right? And if you give it to somebody else, just leave this little text file in the file system somewhere so they know where it came from. It's a notice license. We call them notice licenses at work. And there are other ones like the LGPL, which is the lesser general public license, the MPL, which is the Mozilla public license, and the CDDL, which is the Sun CDDL thing. And it says if you use it, then that's great. But you have to share any changes you make to that particular piece of code. Fair. And the GPL says if you use it, that's great, but anything you link to it, you got to share it too. So it's sort of like a continuum of how much you have to share. And none of these things require you to do it until you ship it to a customer or some sort of third party outside your organization that is in a paying sort of relationship with you. So it's really simple. You can do basically whatever you want with this stuff until you ship to a customer. Then you got to basically take part in these licenses. And they're often very, very easy to take part in. Like the Apache license, big deal. You got to leave a 1 kilobyte file in your distribution. Who cares, right? So yeah, and we can go on and on about licenses. I can be here till 11, or 12, or my flight leaves at 6:30, whatever. So I can talk about licenses till I'm blue, until you're blue in the face. And what's the school color? It's not blue, right? So yeah. Oh, it is blue. Oh, so that's convenient. He's got an orange shirt. All right. So you might be saying to yourself, wait a second. Isn't software valuable? Why would anyone release all this valuable software? Well, it turns out if you ask them why they're releasing all this software, they have reasons. We had a study, and by we I mean my previous we when I was at OSTG and Slashdot. We had a study of SourceForge software developers, people who actively committed in a project and ran projects that were active. And we asked them why, and you can see why, which boxes they checked off, And you'll notice that, hating Microsoft was a pretty minor reason. And I was actually really happy to read that because it sort of matched what I had, in my brain. I'm not really an anti-guy. I'm a very positive fellow, as Dan can tell you. And it was really about growing. It was about thinking. It was about learning new things. And that's pretty cool, And it's remarkable. And this is one of the reasons why I think open source software is as good as it is because people are trying to make good software. They're trying to expand their consciousness. And I think that's really important. But let me continue. So I threw the slide up, and I decided to keep it for this talk, although it's really excessive. Raise your hand if you have an iPod. Raise it higher so I can see it. I'm old. Good. Or any MP3 player? Raise your hand. So you've all used open source software in the form of output from GCC. And I know that sounds really easy for me to say, much in the same as I'm saying it for cell phones and all the rest. Unless basically you're running something that needs hard real time, you're probably running stuff that was written using GCC. And in fact, most embedded electronics, it's easier for people to use GCC than to go and spend a lot of money with Wind River and the rest. Wind River, I guess, is one of your alumni. The dude, well, not the whole company, but one fellow who started it. What? Yeah, Jerry. Yeah, okay. But the point is, the output of GCC isn't everything. And open source software libraries aren't anything. How many of you are running Windows, a Macintosh, or a Linux? Raise your hand. Yeah, so you're all using open source software. And the point is, it behooves you to be smart about it, to understand it. And one of the ways we help people understand it is we help them understand how we use it at Google. And that's why I think you're having me here. So it's a good time to say you can ask me a question about anything at any time. So even while I'm drinking water. Oh, yeah, so I just said that. Yeah. Okay. So how can you get started with open source software? It's very, very simple. You got to find them, you got to work with them, or you have to start your own thing. This is like a 9-point plan for you to go and join the open source software development world. But what it comes down to is if you've got a compiler, you can take part. And we have a free compiler. So, it's really quite easy for you to do. But back to Google, more about me. More about you, Dan. How do you feel about open source? No, all right. So basically, Google uses an awful lot of open source. We use Linux. Every time you go to Google, you are using a Linux machine, remotely, admittedly, but you're using it. If you go to things like Gmail or some of the other services that go over SSL, you're using OpenSSL. When we maintain these machines, we're using a crap ton, and that's, again, a technical word, of SSH, right? And we use a fair amount of Apache tools as well. We don't use the Apache web server very much, but we do use a lot of the libraries. So, yeah, and obviously we use compilers, we use languages, we use Python, we use C++, we use C. So yeah, it's important. This open source stuff is how we built our company, and it's why I'm employed, right? So yay. And we even use some data toolkits, widget toolkits like the Rails and all the rest. We use those more internally. We tend to write our own for the outside-facing stuff because we have sort of different concerns than the generic toolkits have. But yeah, we use a terrific amount of this stuff, and we want to continue that. And also we want to make sure that open source is really healthy. But why? Right? Why do we do this? We got some money in the bank. We can go buy stuff, It's not about money, clearly, right? So why do we do it? Well, as you can undoubtedly read, we really do want to control our destiny. We don't want anyone to be incentivized to say no, or to say, well, you could grow more, but you'll have to pay us. We don't want to be in a position where we're being controlled. Let me tell you a funny story. And this is actually not an anti-Microsoft story, although they do have a starring role. It's funny. It's really hard to have this job without mentioning Microsoft. In the second you say that word, that's the headline, right? I gave those pictures I showed you earlier. I gave this talk at Linux World, and I said, "We like Linux. Look at how much Linux we use. Linux, 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 Linux." And the headline the next day was, "Google uses Linux to go after Microsoft." And it's and there's a picture of me going, "Linux." Didn't mention Microsoft once, but anyways. So French Telecom. Went to go ship a phone. And this was one of these phones with the push-to-talk capability, which I'm sure many of you know what that is. It's, hi, I'm over here. Oh, you are? Great. Okay. No dialing. You just reach your friends. Shipping a phone for a cellular phone company is a multi-year endeavor, usually. It takes between, 18 months to 2.5 years to ship. And there's a lot of reasons for that, and I don't want to go into the cell phone thing. But, so they built out all the carrier infrastructure for the push-to-talk. They found this great phone that they wanted to use, and they were going to use Windows Mobile with it. And they found that as they're getting closer to launch, about every 5th call was getting dropped. Was getting dropped. And they got some smart engineer, and he was working on it, and he's like, I found it. It's this one DLL. This is where it's happening, right, in the operating system. They said, great, go talk to Microsoft. So he went, talked over to Microsoft. He said, hey, I found this bug. I should probably do this in a French accent for it to be funnier. I found this bug. I had a friend that was convinced if he just said at the end of every sentence, it sounded French. Right? So I found this bug, Mr. Gates. And they said, well, great. Oh, yeah, no, we know about that one. We've got a patch for that one. He's like, fantastique. And they said... and he said, fantastique, I'd love to have this patch. And they said, well, it's really late. And they said, well, we'd love to give it to you. However, it's in the next operating system revision, so why don't you take that? And he's like, oh, that would be fantastique. Fantastique is like this perfect French word. When can I get this? And he says, well, it's going to be out in 18 months. He said, 18 months? Sacre bleu. Sacre bleu, we are shipping in the 3 months. And they said, well, unfortunately, we can't help you. And that's what it comes down to. So as an engineer, you are going to go and work at companies, and a customer will come to you and say, I need this change. And someone will say, okay, to maintain a separate branch of our software will cost X. This customer is worth Y. And if Y is greater than X, they get what they want. And if Y is less than X, they do not. Since French Telecom represented only 7% of Microsoft's Windows Mobile business, they did not get what they wanted. And so they shipped a phone with an extra button. And that extra button was like a mute button or a second mute button or something. But it wasn't a push-to-talk button. And they couldn't ship what they wanted to ship. And they couldn't ship the feature they'd provisioned to ship. And it sucked for them. And they had to wait 15 more months past shipment to debut the feature on that particular phone. And of course they didn't. They just had another phone in the pipeline by then. And they got to ship late. And that sucks. So, since they relied on somebody else, they were controlled by somebody else. And we make these decisions all the time as developers. We depend on others all the time. The nice thing about open source software is, at least in the software layer, if we want to make a dumb change, if we want to fix a dumb bug, we can just do it. We can decide, as a company, that it's worth doing. It's worth spending X with our engineers to fix Y, if it's not being fixed in the outside world. And that's extremely powerful to us. So, that's really important. There are also times when you want to do things with your software that are a little weird. Okay, we have a piece of software that we use for managing all of our services that wants you to be able to use ports under 1,000, even if you're not a root program. And so we just made the change in the operating system to make it possible. It was very easy for us to do. It was like one thing you change, and boom, you're done. We didn't have to go out and get a special kernel. We didn't have to go out and get a special license. We didn't have to get a source license. We just did it. Because of the Linux kernel, we could do it. And in the end, it's very, very powerful. And it removes a lot of friction that you find when you're trying to do real work. Because you don't have to ask anyone's permission. You don't have to bring in the legal team. You don't have to bring in the biz dev team. All great teams, all very sharp. I have to tell you, Google's legal, biz dev, PR teams, freaking great. Best in their class. But you know what? They're all really busy. And do you really want to worry them with this kind of thing? No. Especially if you don't have to. And we don't have to. We can just do what we want. And that's extremely powerful. So let me continue. So every time you use Google, you are using open source. It'd be better if that was all in one line, right? And in French. So how do we take part? Google, do you just take and take and take? Well, you could. That's what the licenses say you can do. But we try to do more. So we have all these programs, blah, blah, blah. I'll go through these one by one, detailing in excruciating detail. No, not really. In fact, a lot of them we don't even talk about at all. Like industry trade groups, I go to meetings. Pretty exciting, huh? Let me go into that in detail. I mean, I like it, right? I just sent one of my engineers to Vegas. You're going to the LUAC meeting. Oh, no. I'm going to Vegas. Ooh. Oh, I'm working so hard. I'm just kidding. It's Greg. He works very hard. So. But yeah, let's continue. So code release. We release a bunch of code. We've probably released 500,000 to 1 million lines of code to date. I mentally increment that number because I've got a guy on my team who does a lot of this work for me now. So I just say, it's increasing at a pretty terrific rate. That's great. You can find it all on code.google.com. Just type in Google in the code.google.com search and you'll find it. There's a lot of stuff in there. There's stuff that's both API implementations, but also developer tools so you can make software just like we do. using R malloc and R thread libraries and this and this and that. So please take part. Obviously, we haven't released everything, but more is coming out all the time. So I think this is sort of the base behavior of how you interact with the outside world is by releasing code so that people like yourselves can take it and say, oh, that's how they did that. How exciting. So this is, we also host code for you. So if you want to work on an open source project, so you all know about SourceForge, right? Raise your hand if you don't know about SourceForge. Yeah, so we like SourceForge. We wanted to do something a little different. So we started doing this with our project hosting. And a lot of people seem to like it. We've got a lot of projects up there. But I listed a Google one because I'm from Google. Anyway, this particular one is a JavaScript module that will prettify your code on a web page. So if you show a piece of code and you want it to be pretty, we can help you be pretty. Yeah, but right now, Google Code's hosting stuff is pretty cool. We have this pretty great Subversion server that's extremely scalable and reliable, and a really good bug system. We're coming out with a file really soon. Just keep an eye on it. It's pretty exciting. Donations. Okay, so we spend a fair amount of money. I'm really happy that I'm speaking at UIUC because I'm actually funding some work here. I didn't get to run into the person who I'm funding unless she's here in the audience. No. Okay. Yeah, because it's 8:45. It's 9:30, and she's probably at home with her family. As I should be. No, I'm kidding. My wife is so patient with me. Anyways, so we fund a great deal of research and other exciting things in both universities and outside of them. You saw recently, I'm sure you saw recently, that the Linux BIOS project has been moving forward at a pretty remarkable pace. That's partly due to our donation, partly. They do the work, we just give them money to do it. So there's a lot of exciting things going in free BIOSes now. There's this OSU open source lab. We spent, I guess, $300,000 last year on that, helping basically pay for infrastructure for groups like Debian and Apache and Mozilla and all the rest. We do some things that are more speculative, like this anti-phishing work. And we released an OCR library recently, spent some money on that. It's all very exciting. We're trying to move forward the state of the art. In a lot of ways, that means getting some software out that maybe wouldn't be out there anyways. And we do some things just because we're soft touches, right? MIT, when they moved the CSAI lab into Stata, the Stata Center is this beautiful Geary design building. It's all like freaky and weird and pokey. They even had a web page up that showed 1,000 leaks, like every single leak. And as they fixed them, they took them off the page. So basically you can't make a Geary building without a lot of leaks is kind of long and short of it. But when they were moving the buildings, they opened up this door to a supply closet, cleaning materials closet. And inside were 25 years of 9-track tapes. And there were the backup tapes for the CSI AI lab going back to 1969, right? And they were just sitting in this closet, right? And they were old, really, really flipping old. And I have to tell you, 9-track does not age well, right? So they called us up and said, we need to buy a 9-track tape reader. I'm like, really? And they're like, yeah, we found like a terabyte worth of 9-track tapes. And it's, oh, by the way, the history of artificial intelligence at MIT. You just threw in a guy's trunk? I mean, what the hell, And they're like, well, yeah, so we need to buy a tape cleaner, and we need to buy, and by tape cleaner they mean tape cleaner, right? And we need to buy a 9-track tape reader and do all this other work. It costs like $20,000. I'm like, okay. Yeah, we'll do that, right? So we funded them. They finally got it all dumped off, and it was really funny because Richard Stallman's like, so that's all my email, right? And we're like, but yeah. He's like, I'd like to go through that before we release that to the public. Which I thought was funny and ironic, Richard Stallman's telling me not to release something. Anyway, so Imara is giving laptops to poor kids in Africa. OLPC, 1 laptop per child. Remember the board. We put $2 million into that. And then, of course, there's my favorite topic, the Summer of Code. So the Summer of... They're like, yeah! Woo! Yeah, I'm like a rock star to those guys because I yell at people on mailing lists and they see me do it. I'm not that cranky. Am I cranky? No, see, they have to say that, No, actually, you don't. You're all paid now, right? You're all paid? No waiting on T-shirts or anything? You got your T-shirts from last year? All right, good. They're all wearing them. That's so cool. It's like a rock star thing for me. I see these guys. I'm like, yeah. So, Summer of Code. You can see the numbers. We took 6,338 applications from over 3,000 students that were directed to 100 different open source organizations, which had 1,200 mentors going through them all, and selecting 630 students from 456 schools in 90 countries for the project. And yeah, so what is it? You're like, so? So basically, once someone is accepted, right, so they apply. The SF goes through it and picks who they want to have work with them. Just for getting accepted, you get $500. Yay, $500. And then the student gets to work with basically a member of in this case, the Apache Software Foundation. There are 100 different organizations. You know, the Python people, Perl, you name it. All kinds of prominent projects like Mozilla take part in this. So they work with their ASF mentor, in this case, to create their project. And then halfway through the summer, their mentor comes back and says, well, they're doing great, or fire them. And if they're doing great, they get another $2,000. And they keep on working. And then when they wrap it all up, a couple of months later, a month and a half later, they get another $2,000 from us. And the project's done. Yay, everyone had a good summer. Now, that's sort of the idea. They also get a T-shirt. I forgot to mention the T-shirt. So did your certificates come in the mail, like, jumbled up and messed up, or were they okay? Okay, good. Because we had a couple students that are like, it looks like a dog ate it, you know? So we had to replace a bunch of them. But that's always true. You can't ship anything nowadays to Brazil. It's a global program. 90 countries is non-trivial to handle, I should tell you this. So here's the applications per country. So you'll see the top one is the United States. We got over a quarter of our applications from the U.S. India's number 2. Canada's number 3, because, you know, Canadians. Huh, who knew? And is that French? The Germans are always right next to the French. And then, you know, United Kingdom, Russians, Spaniards, Brazilians. So here are the accepted students. Jawohl, mein Kommandant. Yeah, is it too early to make jokes for World War II? You know. So here was the distribution of accepted ones. You notice Canada's sort of moving up in the rankings here. India's moved down a little bit, and France, and China showing up over here. So this is pretty exciting. We're really happy about this. We would love to see, I mean, nothing personal, we would love to see more of these, and maybe a little less here, but, you know, we're pretty happy about it. So there's no reason any of you shouldn't be applying next year. It's $4,500. Better than flipping burgers. Not that there's anything wrong with flipping burgers. My wife being a chef, if I don't say that, I'll get in trouble. Yes. Yeah, so I spent $3 million. It's more a ratio thing than a country thing. I didn't really... Oh, yeah. I think I'll get to that. If not, I'll answer that for you. Yeah, so mostly undergrads, a couple masters, a couple PhDs. But I mean, if you think about it, there's also less masters and PhD students in the world, so this might be more self-selecting than indicative. Might be more correlative than causal. So we had a mentor summit over the weekend. And it's not just computer scientists. It's people from all kinds of different disciplines, mostly CS people. I'm not going to lie to you there. These are our mentors. We had them all out to the campus. This is the Google campus. And, yeah, so not all of them, just, you know, about 100 of them. So talk about next year. Talk about all of you. Yeah. Well, actually, I did load this up. This is actually a really cool demo. Hold on a second. Google Earth cannot establish a new session with Earth server. Oh, okay. I probably have to relog in. Let's see. Yeah, we run Google Earth on Linux. Don't you? How many of you are running Linux today? Good. That's awesome. Are the rest of you Mac people? No? Mac people? Okay, good. Nothing wrong with Windows. Well, I play Half-Life. I need Windows. Sometimes, you know. Do we have some gamers in the room? Yeah, all right. I talked to some of you earlier. I love flipping Half-Life. Oh, so good. So let's turn on the mentors here. Okay. So this is a little map of where all of our mentors were. Obviously, that's just the United States, but we have other countries too, and little islands, and Australia. Crikey. And, Europe is pretty remarkable because there's all these countries sort of packed in. It's like the TARDIS. Well, anyways. But the cool thing is when you turn on the students and the relationships between mentors and students, you see a whole different picture. This is why this program is so darn awesome. Basically, it's people all over the world working with people all over the world to build software to be used by people all over the flippin' world. So it's pretty cool. Sometimes people make jokes, though. They say, oh, I'm living in the middle of Palmyra, an atoll in the Pacific where nobody lives. And it's like, yeah, sure. But yeah, no, so there are people all through the map, and it's pretty darn exciting. So this file is available, by the way, on code.google.com, and you can click on people and see what they worked on. And here's a fellow, Artem Mendeleevtsev. And he worked on XWiki, and this fellow worked on a Czech translation of Firefox, I guess. And some of them aren't as detailed. And a Plone content rules engine, I don't even know what that is, but it's cool. Import filter for WordPerfect graphics. Yeah. So all kinds of exciting things going on here. So Summer of Code is by far something I'm probably the proudest of. It generates a lot of new code, generates a lot of new developers, and it really shows you something you can't get in school. And while I love school, and I think computer science programs are really awesome and important, this will show you what users need. This will show you what users really, really want, and you'll have to perform to it, and that's pretty cool. And you get paid for it, which is nice. But I mean, in the end, you really learn like this core of developing that is hard to get in college. But I think some colleges try. But it's pretty exciting. So somebody asked about, it was you, who asked about success rates, because this is a program in which you are judged for the quality of your work. And so people do fail. People die. People get sick. People get married. And then lose all concept of priority. No, but I don't know. I love being married personally. So the point here is that we did have some people fail both years. The first year, our success rate was actually higher than I sort of expected or kind of even wanted it to be, which sounds really kind of mean, I know. So it was, I think it was 84% the first year success rate and 82 this year. And that means people aren't being hard enough. But anything over 2/3 I can be pretty happy about. We budget for perfection if everybody manages to succeed. But this year we even took 30 people more than what our theoretical top-end budget was because we knew some people would fail. And it sort of helped a little bit. But yeah, it's pretty exciting. And I really like that it's performance-based, so it's not just, you show up and you get the money. It's because I think that would attract a different kind of student, and one maybe I'm not as interested in. It would attract people who really want to work with their mentor, and I guess the extra added financial bonus is nice too. So yeah. So any questions? You can ask me pretty much anything. We have a ton of APIs, by the way. If you go to code.google.com, you'll see them. You can do a lot of things with Google you wouldn't imagine you can do. So I suggest you do it. So, questions? Yeah. How much do I have to work during the summer? Oh, yeah. So some students found that they could work another job during the summer of Code. But honestly, some of the ones who failed were because they misjudged their workload. I mean, this is some fairly serious work. So yeah, it's hard for people to do both. This year coming up, we're going to give quite a bit more advance notice on who gets in, who doesn't, so that people who are worried about getting a job can sort of have that security that if they just perform to it, they'll do fine. Yeah. So yeah. How did I judge the mentorship aspect of the project? How do I review the mentors? I don't. So. No, I really don't. So the point is, Greg Stein and I, in the open source office, we know open source pretty well. So what we do is we selected projects that we respected. The first year around, there's 40 of them. This year there's 100. And we say to them, okay, your job, project, is going to be to go through the applications, pick who you want to work with, and then judge them and tell us if they managed to do what you told them to do or what they said they could do. And so we trusted the orgs to do that. And it's another way you can scale something like this in the end. We also gave each organization $500 for every student they got. So like Apache took on like 38 students, so they got, $20,000 approximately. So, yeah, did that answer your question? We don't want to control open source software. See, there's two things you have to realize about this project. It doesn't require that the organizations take the code from the students, and it lets them decide what the success metric is. Because we really don't want to force some sort of like structure on these groups, because either they already have it, or they don't have enough of it and need to achieve it to do the project. And it's actually really healthy for them to go through that. So the only real qualification that we have that we care about is that they're a student. So you have to be above 18 and a student. So if it's international, well, they actually are required to submit a transcript. And it doesn't even have to be an official one. It can be unofficial. But yeah, it's kind of not the problem we've found. If someone's going to be dishonest, they can fake up whatever they want anyways. They'll say, I'm a Botswana student from this college, and how are we going to be able to check that? Right? So it really only comes up when there's a problem. And then we go back and we look at the transcript and see if they're legit and all this other dumb stuff. Or they become like, say, well, we have a process that we call arbitration. And that can happen when a student disagrees with the mentor's judgment of them. And there are a lot of reasons for that. Either they say the mentor has not been appropriately communicative with them, or they're insane, or the mentor's insane, or Google's insane, or some level of insanity has entered the system. And so we go through and we review whether or not the person should get the money, should get half, and we deal with it. And at that point we'll say, okay, well, let's look a little closer into all of their application details. Let's review the code personally, that kind of thing. But yeah, no, we just ask for transcripts, and that's enough for us. So. Well, so this is the funny thing, right? During the beginning of every single year of the Summer of Code, which is only 2 years, so every single people bring this up. They're like, I found a hole in the process where I can sneak through. Da-da-da-da-da. And it's like, you know what? The cost of that is at most going to be $500 for me, because people are inherently dishonest. I don't think they're going to deliver. And if they deliver, what do I care? So it's hard getting worked up about this. In a program this size, I can guarantee you someone's going to try to rip me off. And by me, I mean Google, of course. And you know what? I'm willing to get ripped off a couple of times to serve the 628 other students from the 2 that are scam artists, Well, I care a little bit about it because we do fund these kinds of people outside of the auspices of the Summer of Code all the time. So, yeah. If somebody really has the talent like that, if Summer of Code serves to introduce them to open source, I don't know, it's really for students. So that's not so good. But, I think that most open source projects want a level of honesty from people. And so I think it's resilient against that kind of thing. And maybe I'm just, rose-tinted glass, blue sky optimist about things like that. But, yeah, maybe I am. Yeah. Entertaining issues between the mentors and the students. Well, the most common one was people who didn't judge their time appropriately. Like they thought that they could do 2 things at once. And those 2 things could have been a job in the Summer of Code, or getting married in the Summer of Code. Or, and I don't mean that in a bad way. Most of them, there was 3 people got married. 1 had a problem. The other 2 were great. Sent us pictures, So, it's always about somebody overcommitting. And then there were the times when the mentors were bad, and we had to basically pluck a mentor out and replace the mentor. And that just means I call up the administrator of whatever project and say, okay, this mentor's out. And they go, what? It's like, yeah, he's being a jerk. Get rid of him. They're like, okay. You know? And they're like, yeah, we thought that might be a problem. I'm like, then why did you include him? General health claims, I don't know, probably about 5 students during the program. Whether one kid got tuberculosis, there was some natural disaster somewhere that got another kid. Oh, and there was an Israeli kid whose like house wasn't bombed, but like one down the street was, and he was like freaking out, and he had to move, and we gave him extensions, you know. Yeah, we're so generous. We said to the kid who was bombed out, have another week. Well, we actually gave him an extra month or something. The thing is, it's not hard for us to be generous about things like that. But what we found was that there were some students who just were not up for the program, and that's too bad. But I think there's a certain number of failure that should happen in this project, and not because I want to fail people. Nobody wants to fail anybody. Nobody wants to fire anybody, right? But if it's all 100%, that means they aren't reaching far enough outside their communities and trying to bring people into it, in my mind, right? So I'm kind of cheered that we are still trying to reach new people. You know, and there's a case, you know, we had one student this year who failed last year and did a great job this year. And sometimes it's just, you know, their place in their development, you know? So, yeah, entertaining, though. You want entertaining. The bomb story was kind of entertaining. In general, there's some people who come in who have familiarity with the software already, but are students and need something to do over the summer. And that's an okay thing, too. There are a lot of goals to this project. I mean, we want to keep computer scientists. So the genesis of the Summer of Code is I was in a meeting with our founders, Larry and Sergey and Eric Schmidt, and we were talking about things. And they said, what we want you to do, we got a project for you. And I'm like, well, okay. And they said, we want you to find all the students who aren't doing computer science over the summer and keep them programming. And I'm like, okay. They're like, spend this much, try to help this many students. I'm like, that's a lot of money. Okay. And so I left and I'm like, well, why are they asking me to do this? I'm the open source guy. Well, probably because I am the open source guy. So how would the open source guy do it, right? So I called up all my open source friends and said, hey, you want to take on some students this summer? And they're like, what? I'm like, yeah, it'll be fun. They're like, okay. So that was the first year of the Summer of Code. And it was pretty exciting. We put it all together in about 2.5 weeks and launched it. And it was a pretty fast launch. It was funny. I don't know, you used to work for Debbie Jaffe, or you knew Debbie? You worked with her, right? So Debbie came to me after I launched the first Summer of Code. She's like, Chris, do you have a second? I'm like, oh, sure. Hi, Debbie. How are you? I've barely talked to her maybe twice since I'd been at the company. And she runs like all of external user-facing UI, right? Marketing. And and she says, so this thing, the Summer of Code. I'm like, oh, yeah, what do you think about that? She's like, you could have talked to us. And I'm like, and then I had like 4 other people, like this little line, you know, when you launch something like this, we can help you. And I'm like, excellent. Because I didn't know any of these people. It was great. It was a great way. If you want to meet anybody at Google, just launch something. So Dan's like, going, hey, that's not how it works anymore, man. You know that, right? Yeah. Even more female. Not enough. Oh, that was cool, though. Wasn't that cool? He ruined it. Oh. Just go sit down. Do you want to handle the little... Do you want to handle... talking in my water. What time is it? Wait, so, women. So, unfortunately, our program mirrors the population numbers of women in open source, so it sucks. It was like 5% women. So right now, women graduating from computer science school is, I think, at 16%, something like that. Masters, it's quite a bit better, actually. But yeah, undergrad, it's like 16%. Open source in general represents at around 4 to 6%, depending on how you measure, and how accurate your measurements are. So I think it's more towards the lower number than the higher number. I think the higher number is wishful thinking, the 6%. So, but yeah, so we're right in the middle of that, which I wish it was better. So one of the things that happened this year was the GNOME folks said, we're going to do one that's focused on women, because we did not get enough women applying. And we're like, cool. And they're like, you want to pay for it? I'm like, sure. So they had sort of this other program as well, the Women of GNOME or something like that. And It's just sort of a funny title now that I think about it. But it worked out really good. They had a terrific, they really had a great experience in that program. And there were some women who took part, and I think they did well. I don't know like success rates or anything, breakdown by gender, but yeah. So I think that answers your question. Yeah. Oh no, you're scratching your head. You. Did I actually answer your last question? I can't even remember it. Okay, go. No. Yeah, go ahead. Yeah, sure. Oh, you had Richard come on. Great. Did he wear the hat? Yeah. Excellent. See, the great thing about Richard is he makes me look normal. Actually, I don't like indulging in Richard bashing. I know I did. I try not to do it because it's worth pointing out. He did remarkable work. I mean, this stuff would not be where it is today without him. So, but go ahead. Really? He said that? That's too bad. Because I think he's wrong. So my opinion is this. Do you want to go through your computer science lives redoing work, or do you want to do new work? Open source means you don't have to redo work, for the most part. You get to use other people's work. You get to ship products with other people's work, and you get to build on everybody else's work. Isn't that cool? So it comes down to this. Do you think that computer science is going to stagnate? Do you think that the creativity that you can articulate with computers is going to stop? And if you do, well, then you will not get a job in open source. In the end, open source is just software. And it's just software with a special license. And you know what? You can build all kinds of software with all kinds of licenses, either from it or with it or to replace it. So I think that there's plenty of opportunity with computer science right now. I don't think that open source makes that harder either. I think it makes it better for you. Being familiar with these kinds of tools and libraries and operating systems is very good for your career. I know that we look for it when we're hiring people. I see those resumes. But I think it's also dangerous to say, I'm going to be an open source professional. Because in the end, you're a software developer, right? And I think that software is just software. So if you think there's a future in software, which I do, then there's a future in learning how software works. And a lot of that means learning how open source works. So I think it's a shame that... So that said, open source software does change license revenue a little bit. And I do mean a little bit. There's this great Merrill Lynch study that nobody's read because it's kind of scary, that says that for the enterprise software market, which, by the way, I hate, because you have to do a lot of salesmanship and all this other stuff, but luckily I don't run our enterprise division, right? Dan's like, he doesn't run the enterprise division. It's run by a very talented fellow named Dave Gerard and a great engineering manager named Ricardo, so it's in good hands. But I don't want to diverge too much here. The thing about the enterprise software market is you spend so much time selling sometimes, and you spend so much money selling enterprise software, that it's actually, you end up spending something like 80% of first year license revenue just on selling it. And then it's like 30% of first year, of second year, and like 20 of the following years. Just maintaining the sales. That's not support costs, that's not development costs, that's just the cost of sales. So it's like, I think a lot of people look at that and say, you know what, license revenue kind of sucks anyway. Let's try to move away from that. And a lot of people have. You see it in the sugar CRMs, the Hyperics, the Compieres, that kind of thing. But I do think that there's a lot of places where there will be no open source software. And that's actually specifically within the realm of the games. Because games are more about on-demand creativity and art and story. And it's got to be new, and it's got to be changing, and all this other stuff. I think the game engines, there's a lot of actually really good open source game engines out there. But I think that the actual assets that go along with them will probably remain closed source for a very, very long time. Much in the same way that movies will remain closed source for a very long time. So I think that answered your question. But I want to stress again, learning software, learning open source software will not limit you. It will expand you. Much in the same way learning any software will. So, any other questions? documentation, right? So we've entertained ideas on doing like a summer of docs or whatever. Documentation's hard, man. Luckily, I worry about open source code. But there are a lot of people who actually worry about documentation. I think we're actually in a golden age of documentation. I should say this. So I've written a couple books about open source software. Yay me. Go buy them. There's a great site called php.net. How many people have been to this website? Just raise your hand. So this is a great site. This is the future of computer documentation. And let me tell you why. Suppose you want to know anything about PHP. You say, okay, I want to learn about the HTML entities command. You type that in. And it brings up this great page. And I should even bring it up. Not that I'm a big PHP head, but... caps lock fever. So I'm going to type in HTML entity. It'll go ka-chunk, ka-chunk, ka-chunk. I'll make that bigger. Hold on. Boop. So, and you get this great page, right? You're like, good, that's wonderful. But the cool thing is, so you have this standard stuff. You have a little example. You have supported character sets. You have a description of the thing, the arguments. And then you get into this sort of like long comment stream about all the little funny corner cases of the command and all the ways you maybe should consider using it and all this other great stuff. So, the point of this being is that I think the documentation is going through a remarkable change. And if you talk to people like Tim O'Reilly and the rest, tech books is a terrible market to be in. Terrible. Because they sell to a certain degree, but it's not like it was. So 20 years ago, a book would sell, a solid tech book could sell 25 to 30,000 copies. Right now, they start their print runs at 3,000 copies. And that should tell you something. There's so much online now that it's a matter of finding it usually, more than anything else. And so Google has done a remarkable thing there in just helping you find crap. And other search engines. So I'm not being facetious there. I mean, you're so much better off as developers today than people were just 5-10 years ago. There's so many great tools out there, including Google Code Search, I might add. I'm trying not to turn this into a big sales thing. But things like php.net, things like wikis attached to projects, it's just remarkable. So Google Code Search. So, boop. So yeah, so suppose you were really curious on how a binary tree worked. Right, so you just type in binary tree, and poof, there you go. We have stuff that's in Java, we have stuff that's in all kinds of things. Anyways, so the point is, you're so much better off now than you were 5 years ago. And it's going to get better. Now, that said, documentation always stinks, right? Documentation's always out of date. Documentation this, documentation that. And that's too bad. I wish it was better, but it's not. So the great thing about open source, at least, you can dive into the code and see just what they meant, even if what they typed about it was wrong. So, anyone else? I could do some funny things here, like broken. Yeah. I don't think it is. I'll check. What's that? Well, I saw somebody videotaping it with their camera. You mean like poke me and like kick my butt and take my laptop and run off? No. I have to check. That seems like something that's like a 4-year-old video now. We should be able to release that. I'll check with Rob and with the other people. I'm sure I can. Just email me, cdibona@google.com, cdibona@google.com, and I'll check. I'm sure I can. It's really old, Yeah. So, anyone else? Yeah. No. Oh, 20% time? 20% time? So 20% time is this thing we do at Google where we allow you to take 20% of your time, shocker, being called that, to work on another project. So what does that mean? Does that mean you go fix your car and walk your dog? No. It means that you find another project at the company that interests you, or you create a new one that interests somebody, and you work on it. So usually what ends up happening is people will sort of bunch up the time and then try to work on it like that. I have a pretty nonlinear job, right? So I probably have 8% time Is probably what I've taken since I got to Google, which is too bad because my 8% project's really cool, and I can't talk about it. So, but boy, when it goes out though, you'll know. But yeah, so trying to think of what other. Do I have any other 20% projects I can talk about? I'm trying to think of what I signed on for. Yeah, so I can tell you some of the projects that became real projects from 20% time projects. So Orkut, Google News, Gmail, a couple of other. There's a bunch of features and maps you don't know about, but came from 20% time. Oh, Mars.google.com was one of the ones that I worked on. So hey, that's the best site ever. You know it. How many of you have not seen Mars.google.com? Oh, then I'll have to show it to you, won't I? As you can imagine, it's flipping Mars. Oh, so there's like a secret one you can tie into if you have Google Earth Pro Plus Extra Extended Edition. But we've been working on it. It'll probably come out in the next quarter or two. We usually don't say things like that at Google, but it's Mars. Who cares, right? Yeah, well, it's important to have all the developers. You can actually add the Mars map in a Maps API map. It's just kind of harder to find. So let me. There's like a really. Where is that crater? Is it here? Wish Michael was here. He could show me. There's this great image. It's well, you know, and we're also getting the new high-rise images from. There's a new orbiter around Mars right now, and they actually have a picture from space of where the rover is on the side of that one crater. It's really cool because you can actually see the track, and these images don't get that high res. They get pretty flippin' high res, but not that high res. Let me go to the infrared image. Oh, there you go. So. The giant insects over Germany. So the way we get Google Earth and Google Mars data is we buy both satellite imagery and overflight imagery, which means literally a plane flying over. Let me zoom out here. Yeah, so this is like, I think this is like 10 or 5 meter per pixel imagery here. So it's really cool. Anyway, so big flying bugs. I can actually probably bring that up really easily too. It's exciting, I'm telling you. Bug Germany, Google Maps. So this is, in case you don't know what I'm doing here when I type in here, Firefox, if you just put junk like that in there, it goes to Google, says, what's the first release for that? And they'll say, oh, well, that's this over here. And 9 times out of 10, it's basically it's like hitting the I'm feeling lucky button. So this is the first person who found it. So I'll just click on theirs, and poof, there you are. Yay. Yay, search engines. So, so here's our friend the bug. We think he's an earwig. So what happened? What's funny is because in hybrid mode, of course, it draws the lines over the bug. So what happens is we have these orthorectified cameras, which sit on the bottom of planes and take images, chunk, 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 and put geocoding information with them. And sometimes a bug will get into the plane, will walk down into the cargo area, and walk across the lens. And that's what you see here. You see a very adventurous, exploring bug. So all hail the bug. Oh, Google Moon? Well, I could show everything that Google does, but I don't know that you want that. 6:30, yeah. Moon.google.com. So everyone's going to say, oh, you should zoom all the way in and see the freaky little alien shit. And it's like, okay, here you go. Jeez. Yeah, it's funny, when we launched Mars, we're like, should we do something like that? What should it be? And then we're like, well, we have so many images that are actually at that resolution. I mean, how would we do that? And anyway, so we weren't as fun. Yeah. So another Mars. Yes, the face on Mars is just a crater. Another large search engine that's not Google. Recently had a hack day at Yahoo. Oh, Yahoo, yeah, sure. No, it's okay. Please. I'm not like that. So. Yeah, calling them patterns. We should do something like that, right? Yeah, okay. No, we've talked about it. I mean, actually, quite a bit. To date, we've done more targeted invitations. Like we had all the version control people in. We had we had something called Science Foo Camp, which was we invited like all the top scientists in to talk about science and stuff like that. But yeah, we haven't done a hack day thing like that yet. We had a Geo Developer Day right before Ware 2.0. That was the closest thing to something like that. But we haven't embraced the whole like let's just invite anybody who wants to come kind of thing. But yeah, no, that was a pretty cool thing they did, and you got to see Beck. So, yay! Still wondering about the Beck thing, but no, it seemed like a really cool event. So yeah. Yeah, no, we sponsor a bunch of the bar and Mind Camp things, and we've had a couple of things like that on campus. But the Yahoo Hack Day was very specific to their APIs, whereas the bar camps and the Mashable camps and the rest are more about bringing together lots of people's APIs. So yeah, no, but the Hack Day thing was pretty cool. So I don't think we can get Beck though, you know. Hammer, right? No. There was something going on at Google where Hammer was coming by like every other week. It was really strange. I mean, because yay Hammer, but it's not. It was a little weird. Bono. He's got those big glasses though, you know. So, yay, save the world. All right. Any other questions, or should we wrap up? It's up to you guys and gals. Okay, I guess we'll wrap up. Thanks for coming. Thanks for having me.